So in this example, we're going to be cutting a board, a rectangular board, out of a tree trunk, kind of a cylinder tree trunk, and we want to maximize the strength of the board. So the strength of a board is proportional to the product of its width times the square of its height. So here's kind of what's going on. So our tree trunk has a diameter of 30, and we're going to be cutting a board out of this. And this is like the center, and so the diameter would go here, right? And so that diameter is 30 inches. And so this we'll say is the width, and this is the height of the board. And so the strength of the board, I'll use S, is proportional to the width of the board times the square of the height. So it's WH squared. Okay? And so what we want to do is we want to know the dimensions of this rectangular board, the W and the H. That's going to maximize the strength of the board. So what I want to do is I need to get let's say like H in terms of W or vice versa. So the way I'm going to do this is this is like a right triangle where the legs are W and H, and the hypotenuse is 30. So we know that W squared plus H squared is equal to 30 squared, right? And so what I'm going to do is I'm going to solve this here for H squared. And so I would get 30 squared is 900, so 900 minus W squared. And so what I can do is I can just plug this in, this whole thing in, for the H squared. So I get S is equal to KW times 900 minus W squared. And now I got all of this in terms of W, and now I'm going to maximize this function. So let me simplify it. So this would be like KW times 900 minus KW cubed. And so notice that for W the width could be can't be 0 or 30 because you wouldn't have any height here. Well, if it's 0, it's just that you wouldn't have any board, I should say. So so we're not going to include those two endpoints, but anywhere between. So we want to find any relative min or max inside this open interval here. So, and also notice if I put in 0, the strength would be 0. If I put in 30, the strength would be 0. Okay, so now let's take the derivative, ds dw, and what I get here is this would just be like 900k, which is a constant because k is the constant of proportionality, and we don't know what that is. Fortunately, we're going to find that we're not going to need to know what the constant of proportionality is in order to find the dimensions of the board that maximizes the strength. So this is going to be minus 3kw squared. And so we set that equal to 0 to find the critical points. And we can see why now that the constant doesn't matter, because I can pull out a 3k. And if I do that, I'm going to just get 300. And yeah, 300 minus W squared is equal to 0. And so and I can just divide both sides by the 3k. And so now I could take the sum and difference here. I could factor this, or I could move the w to the other side and take the square root of both sides. Doesn't matter either way. If I factor it, I would get like the square root of 300 plus w, square root of 300 minus w. And so this would just give me w is equal to the negative square root of 300. This would be w is equal to the positive square root of 300, which is the one that is the one that would make sense, the one that would be in this interval. And let's see what that actually is. So the square root of 300 is actually like 17.32. Okay, so now we know that that is a critical point, but we don't know that it's necessarily a relative max. So let's take the second derivative here of this. So this is my derivative, right? So let's take the second derivative. So d2s, and we'll do the second derivative test. So if I do that, this just goes away. I can bring the 2 down. I get negative 6k w. And k here is going to be positive because we want both the w and the h are positive, and we want the strength to be positive. So we're just assuming k is positive. So if I put this in here, then we know that this is going to be negative. It's going to be below 0 for any value inside this interval, actually. And since it's less than 0, then we know it's concave down, and we got a max, right? So what dimensions then are going to give us a maximum? Well, w equals to the square root of 300, and h equals, now what I need to do is I need to put the square root of 300 into here, right? So if I do that, square root of h is equal to 900 minus square root of 300 squared. So this would be 900 minus 300. And so this would be 600. And I would get h is the square root of 600. And so these would be the dimensions then. So if I actually did this would be like 17.32, and the square root of 600 would be 24.50. This is actually, I'm going to run out of room, so it'd be 24.50 if I round. Nope, to 49 if I round to 2 decimal places. Okay, and that would be the dimensions of the board that would maximize the strength. So in this case, we see that there are times where you might have a constant proportionality, and that constant is going to depend probably on the board, the material itself, and whatever. And so we don't know what that constant is, but it still doesn't mean we can't find the dimensions. That constant isn't a determining factor of what the dimensions are that'll maximize the strength in this case.